Good afternoon and welcome to Math 20 in the PM. I'm your host, Mr. Shindelka. Away we go. I'm talking like this is a radio program or something. Okay, take a look. We've got the same sheet, everybody, right? Now this is kind of like the skills that you may have forgotten or don't have. It's fine. I'm calling it the warm-up for similar triangles and trigonometric functions. Trig functions, though, is what we say. So when you see trigonometric, just trig functions. What are they? It's the sine, cosine, and tan buttons on your calculator. That's what we're going to learn how to use. Before we do, we're going to take a look at similar triangles, okay? Because that's all this sine and cosine stuff does. Now, you might be able to just do this in your head by looking at it, and that's great if you do, but I want you to learn how to do it this way so that it gets easier when we use the sine and cosine buttons. Now, what I was saying was, if this is the same kind of triangle, a similar triangle we say, this 3 and this 6, what do you notice? 3 to get to 6, that's twice as big, right? Now, could you just, by guessing, what would that x be then? 8. Without doing, so this problem, I wanted to choose a problem that's not too tough. We can see what the answer should be. How would I show that with ratios, though? We're going to go like this. Maybe I'll change the color on one of these. I'm going to say, I'm just circling this in blue, so now you see that's the blue triangle. That's just for me. If I say, we've got to set up here. You know, this line equals that line. We're going to have two, that's a ratio, a fraction, right? So if I say that the 3 side, here, what side is that like on the big triangle? You'd say, Mr. Shindelka, it's just like the 6. You can see that directly, right? So you're going to set that up. 3 is like 6. Now, we want to find out what x is. And x is comparable to side 4, right? So, just like 4 is, and I kind of said that backwards, the way we're setting it up, is like x. Now, take a look. Does it make sense how to set up this ratio? Because that's what's important for me. I know you know how to get the answer. What's the phrase that pays? Cross multiply, divide by the lone. We know how to do 4 times 6, that's 24. And then divide by 3. That's giving you the answer of 8, which we knew ahead of time. X equals 8. What the new skill is setting up the ratios for similar triangles. Now, I'll give a second here and wait if there's any questions. Are we all together on this? You're good, and you're lovely. I'm going to zip it up a bit. What about when we don't have nicer numbers? Oh, it says set up for x and possibly y. Well, I can't do them both at the same time, but I'm going to use blue again here. I'm going to just rewrite the numbers so you know where I'm getting my blue numbers from. 1.7, 3, 2. You have them down in black. That's fine to keep them in black. It's just so you can tell where I'm getting the numbers from. Okay, and then I've got, this is orange, isn't it? What color is that? It's reddish? Okay. I'm colorblind, so I can't always tell. Sometimes I can tell. I didn't have that color memorized yet. Anyways, I just rewrote them so you know what my color coding is all about, okay? You might notice this time I have a 60-degree angle in there. That's fine. Oh, the other thing I didn't put in this one here, I notice, is that it's a right triangle, and that's important. If it is a right triangle, to indicate that. This would still work even if it wasn't a right triangle. What we're doing with similar triangles works. But anyways, let's go for the 1 and the x. You see how the 1 and the x are comparable? I'm going to make a ratio that includes 1 and x. Now, never ever do both the x and the y in the same setup. Meaning you'd have x and y, two unknowns at the same time. No good. What I'm going to do though is set this up. I have a fraction set up there. I'm going to say the number 1 is sort of like my x, because they're on the same kind of side, right? Just like, now I can't use the y side because there'd be too many unknowns. Just like my number 2 is like 15. Because they look like the same type of side, just larger in the case of 15. So, my number 2 is like 15. And then I could solve that. Cross multiply, 15 times 1. Divide by 2, 7.5. The math part of it's easy. Have you guys noticed we've been using the same math skill, this cross multiply, divide by the loner, like in about 75% of our problems this year, and you will. It's probably the most useful math skill, even out of school, if you want to figure out tax on something, sale prices, currency exchange, centimeters to inches. That's the way to go. I'm also supposed to solve for y. And I use the same kind of setup, except this time my y is like, I'm going to do it backwards, a y and 15. What's that? My y side is comparable to this guy right there. It's a decimal number, but it shouldn't make it any different. 1.732. And my 15 side, same thing again. It's 15. It's comparable to the side that's labeled 2. That one you will need to use your calculator for. I believe you, 12.99. I can't do it in my head, so. Oh, I was going to write x. It's y equals. How did she do that? She multiplied with her calculator. I'm going to grab mine out too. She said 15 times 1.732. 15. And it isn't 12.99. Oh, divide by 2 then. Yeah. 15 times 1.732 divided by 2, and it's 12.99. Thank you, Peter. Now, before I move on, because now we're going to use these cos buttons and sine buttons. Is there any questions about this part of it? Because I know how to do this stuff. I need to know that you guys know so far, because it's going to be a little bit new. Do you ever remember doing something like this way back when? Maybe? Yeah? Okay. Need a different one? That one's not. Is there something wrong with that calculator? Like, is it blanking out just so nobody else takes it? Oh, God. Yeah, I see what you mean. I'll have to try fixing it later. Hopefully that one works for you. Now, what happens when you're not given two similar triangles? Luckily, our calculators, I'm reading, with the cos, sine, and tan buttons have the ratios built in. All these decimal numbers. Let's use the triangle from example 2, but this time you're going to pretend you don't have. This time, we're going to pretend we don't have this 1, 2, 1.7 triangle. How would you use the calculator to solve the same kind of problem? We already know what the answer is, by the way, for x or y. So we're going to see if we can actually get the same answers. Reasonably close. Okay. We're going to use our calculator this time with the sine and cosine buttons and stuff. So the example here is find the value of y using this sine of 60 button. Can't just jump right into this because this is new. What you need to know first is sine, S-I-N-E. Nothing's working for you? I can crack open something new if you need. It's abbreviated SIN on your calculator. Don't pronounce it sin. If you wish, you can, but it's sine anyways. And that's what I'm talking about when I say sine. You need to write sine with an angle beside it all the time in a math problem. So you never just write down sine, you have to write down sine of 60. Like that's, don't just say 60 or don't just say sine. And the sine of an angle is the ratio of the side opposite to it and the side that we call the hypotenuse. Now, I've talked about a hypotenuse before in the first chapter when we did a squared plus b squared equals c squared. But what is it? The hypotenuse is always across from the 90-degree angle. And that's marked with the small square. This is the hypotenuse, right? Now, I think the word opposite we're all familiar with. That's not too mathematical. The sine of an angle, so in this case 60, is the opposite side. And that's y in this case. I did write down that I wanted the sine. Okay. So how are we going to do this? I'm going to set this up with you. I wrote this down for you the first time. And I'm going to be putting up, I have a poster that I'm going to put up with those ratios on it. The sticky tack wasn't working too well. Let's see if this stays up here. I'll be giving you those values or facts. Anyhow, back to this. Here's what we want to write down. Which angle are we interested in? We're told to look at 60 degrees. So I'm going to start with sine of 60 degrees is equal to the opposite over hypotenuse. So start with writing that down with the word 60, or not the word, with 60 degrees, exactly like that. Then, use your calculator. So, many calculators make you put the 60 in first and then hit sine. You get decimal 866. If you don't, you might be on a weird mode. Let me know. Some calculators you have to hit sine first and then hit 60 degrees too. TI calculators tend to be like that. Depends which model you have. So I'm going to put in 0.866 equals.
I didn't get that.
You didn't. And I bet you, is there a little RAD in your corner? Or is there, because you need a DEG. I'm going to see what your calculator has for. Yeah, see how there's an RAD? How do we fix it? DRG. Degrees, radians, and then gradients. We need it on DEG. You'll hit 60 now and you'll hit 866. Tamika, do you get 866?
Yeah, I got it.
60, I think yours works. Oh, this works the other way. You have to hit the sine button first. And you get 0.866. You get 866? Try her out. You're on the green one, so I think yours goes 60 then. And Miss LaFontaine, yours, I see it. Okay, it's great. Okay, now I put a line over it. Do you remember anytime if you want to make a fraction out of just a plain number, what can you put it out of? A 1. Do that. It makes it then easier to solve because it's going to be like every other problem you solved before, or most other problems. Now, I have to now look at this diagram here, say 60 degrees. I know that sine function gives me 866 over 1. I need the opposite side. The opposite side to 60 is the letter y. So I'm now going to replace opposite with the letter y. And then I'm going to say the hypotenuse. The hypotenuse is 15. You got it. Good. So I'm going to replace the HYP, hypotenuse, with the number 15. You know how to solve this now, right? Okay. And you've got it. I believe you. You got it. And you get the same answer you did the time before, don't you? 12.99. Do you get it? Cross multiply in, divide by 1. Don't be shy, give it a try. So 1 equals 12.99. I'm showing you this way because it's the way you're going to use. It gives us the exact same answer we had before, and it should. It's supposed to. This tells us that we don't have to have two triangles always to solve it because the calculator has all those ratios built in. It's as if you're using two triangles to solve this. It's just a quicker way to do it. Now I'll pause for a second to make sure you can do this. And are you good with it? Great. Kevin, I see you putting something down. And Destin, I see you're doing what you need to do. Okay. Tiana, you're good, right? Okay, let's flip the page then. There's the sine function. We did that one. How about this cosine function? Cosine, cos. It's not Costco or anything like that. It's not a Costco button. It's the cosine button. Just abbreviated COS because you can't fit all the letters in. It's the ratio of the adjacent side and the hypotenuse. Now we know what the hypotenuse means. It's the side opposite 90. What's the adjacent? Adjacent is $1 million word to mean beside. Right next to. So 60 degrees, the X is right next to. That's adjacent to the 60-degree angle. And it has, you might say, well, yeah, but what about this 15? It's adjacent. Well, no, we call that the hypotenuse. This is the hypotenuse. The adjacent angle is always beside, and it has to be connected to that 90-degree corner. That's how I know this is the adjacent side, okay? Now that's going to disappear in a second here, but we'll get this down. So adjacent just means beside, and it has to be connected to the 90. How do we do this problem? We're going to say use the cosine function in 60 degrees. I'm telling you which one to try. So I'm going to say cosine 60 degrees equal to adjacent over hypotenuse. That's going to be your first step for most of these problems. Don't just jump in. Write down which angle and which cosine, sine, or tangent you're using. What it is, adjacent over hypotenuse, etc. Then we can plug in numbers. Just move that up a tad. Got some space. You're going to hit the sine or cosine button. However you take this cosine of 60, whether you put the 60 in first, hit cos, or if you use cos and then hit 60. Depends on your brand. You already know. When you do that, you get 0.5. You got 0.5. So how are we going to write that down? As a fraction. 0.5 over? You betcha. And that's going to be equal to, remember, we're talking 60 and I want to find the X. 60. This is the adjacent side. This is the hypotenuse side. So for adjacent, I'm going to put in the letter X. The hypotenuse, I'm going to put in the 15. Cross multiply 0.5 times 15, divide by 1, and it's still 7.5. Just like the time we did before. And it shouldn't be anything. It's not too bad. Any questions at this point? Now I've changed the triangle up a bit. Same kind of idea. This time, what did I, oh, doggy. I'm going to just change this here. I just was making this up this morning, man. So group, ungroup. How's this look? I had a typo there. Scratch out that one y and we've got to solve for this one, okay? It just, there's a typo on your sheet. So the tangent is the ratio. Let's see what I got there. Of the opposite and adjacent sides. Now, that's what I just said. I made a mistake. That's why. So take your old y, that was here, scratch it out. This is where it should be. Okay? That was my mistake. Okay. Now let's try this out. I think you guys probably have a good idea of what to do. You'd replace tan of theta with tan of 60. Write it down. You'd still put in opposite over adjacent. But now I want you guys to try writing that in, what the decimals are, and solve it. And this is one we don't have the answer to yet. Hi there. Are you looking for someone, or are you thinking?
Yeah.
Oh. People are always welcome. Is it 12.99? Hey, should be. Because when the side up here was 7.5, right? This was 7.5, this was 12.99, right? That's what we're trying to show. So, you got, what was it, 1.732? The opposite was the letter y, the adjacent was 7.5. When you multiplied it out, you tell me you got 12.99. Now this young lady's a fast worker. I'll give you a second here. See if you can figure that out too. Like, don't fool yourself and don't let me move on if you don't know what's going on. Good? You're good? I'll wait for Miss B. Give it a second here. Doing that, I'm making that correction on the other sheets. Did you get it, Kevin? Okay. Miss B, did you get that? Yep, great. Now, where am I here? Fact, all angles in a triangle add up to 180. You probably had seen that before in elementary school, grade 8, grade 7, I don't know. You may have forgotten it, it doesn't matter. Let's use that fact. Find the third angle in this triangle. Now, we're given 60 degrees. What does this square mean? It's a perfect corner, 90 degrees. So that's a right triangle, we call it. Now that's a given. The third angle that you don't know is the smaller one, right? How do we find that? Well, with this one, we're going to say 180 is the total. So if we take out the 90 and the 60 by subtraction,
150.
well, you didn't subtract the 90 off of it, right? 180 minus 90 is 90. For right triangle, well, I'll just let you do it this way. 30 degrees. That's a 30-degree corner. Now, I'll wait for a second here. Boxing the work there. 30 degrees is the answer. Now, as you get more familiar with these problems, if you have a 90-degree triangle, you'll notice that you're always starting with 180 minus 90. And that brings you down to 90. So it really just turns into, after a while, if you've noticed, it'll be the difference between 90 and this angle will give you this angle. 90 minus 60 is 30, and so on. As long as you have a square corner, a right triangle. But you don't have to memorize that. As long as you know 180, you can just subtract 90 and subtract the other angle. Doesn't matter. Time to move on, right? We're good? Your turn. Now I've changed the triangle. It's 17. I'm going to give you guys a chance to try these ones, and then, just a second here. Some of these, I've changed switched the triangle around, but they're all the same thing. Follow the same steps, and what the hey, I might as well do one with you. Make sure that we're on the same thing. Somebody want to work on my board? Because you're such a good student. Nope, you don't. Okay. Okay, fair enough. Use tangent of 17 degrees to find x. And you say from 17 degrees' point of view, this is the opposite. This is the adjacent. We don't need the hypotenuse, but that's the other side. The very first thing you have to do is look up what the heck is a tan? Tan of 17 is going to be opposite over adjacent. You'll do these enough that I hope you remember that, but it's going to be on this poster, which will be up during the whole unit. You can always look back, I'll give you a formula sheet. You go from there, see what you get. Welcome aboard, Mr. Bird. Come on in. I'll get you set up in a minute. Tell you what, too. Here's what we're looking at today. Remember how I said we'll just start with chapter 4 fresh? Yeah. That's today. Starting with chapter 4 fresh. Round it to 1 digit behind the decimal. Tina, what'd you get? Okay, that's fine, to 2 digits. You got 40 point.
For what?
For this problem. Okay, well, I'm waiting for you guys. Yeah. 40.9 or 40.89? 98, okay. Well, I'm thinking...
Wait, let me do it again.
No, I'm thinking you probably had the same answers I did, yeah. 3.057 if you want an extra one. If you want to call it decimal 306, that's fine. My Opposite. Okay. I see. You used 305. That's fine. I would have given you full marks. Okay? Yeah. You should use, because right now I'm just wanting the method. If you wrote that down as just 305, you really should write it as 306, because you see how the 7 bumps it up a notch? That's why you're slightly out by a decimal. Okay? So, I'm going to put down 40.9. Okay, it's not going to make sense to you right now. I'm going to stop my recording here, and then we'll get going on this. Try these problems out, and hopefully I didn't make any more errors on there. Should work.